Hello guys, Engineer Josh here. Now in this video I'm going to be showing you how to simplify fractions using LCM. Now LCM simply means the lowest common multiple. So the lowest common multiple is the smallest multiple that is common to two or more numbers. It is also the smallest number that both numbers can divide into evenly. Now what does it simply mean? It simply means that in getting the LCM of two or more numbers, you first have to list out the multiples of those numbers and then look for the smallest multiple between those numbers that is common to the two numbers. Alright, so we are going to be taking an example real quick to actually buttress on this explanation and see how we can get the LCM of numbers using this explanation. Okay, now when do we actually apply LCM in mathematics? We apply LCM when solving fractions. We apply LCM when simplifying fractions. Alright, so if we have an operation of plus or minus between two fractions, we use LCM to simplify such fractions. Okay, so the first step in actually solving a fraction or simplifying a fraction, alright, with the plus or minus operation is to first find the LCM, and that's what we're going to be doing now. We're going to be looking at how to find the LCM. So let's dive in. Now let's say we have a fraction of 3 over 2 plus 1 over 6. Alright, and what to simplify this fraction. Now the first step in simplifying such a fraction is to find the LCM of the denominators of this fraction. So if we are having the sum of three different fractions, we have to find the LCM of the denominators of the three fractions, depending on the number of fractions we have. So in this case we have two fractions, so we have to find the LCM of the denominators of the fractions. So from our definition of LCM, we're simply told that to get the LCM, we first have to list out the multiples of these numbers. So when we list the multiples of these numbers, we then consider the multiples. Alright, we consider the least common multiple between the two numbers. So what does this mean in real sense? So let's write out the multiples of 2. So we have 2, 4, 6, 8, 10, 12, 14, alright, and so on and so forth. Now let's also write out the multiples of 6. We have 6, 12, we have 18, we have 24, we have 30, we have 36. Okay, now these are the multiples of 2 and 6. Now from the definition of LCM, we're told that to get the lowest common multiple, we have to consider the least multiple. Alright, within these multiples of 2 and 6, we have to consider the least multiple that is common to them. Now if we look at the multiples of 2, alright, the least multiple that we can see here, which is common to these multiples of 2, and the least multiple that we can see here, which is common to these multiples of 6, alright, is actually 6. 6 is the least multiple that is common in the multiples of 2 and 6. So it simply means that the LCM of 2 and 6 is actually 6. LCM of 2 and 6 is actually 6. So that's the least common multiple. Now we have not actually started solving this fraction, but we are one step ahead. Okay, so the first step in actually solving the fraction is to first find the LCM, and we have done just that. Okay, so this is the conventional approach of finding LCM. But what I'm going to be teaching us today is a different approach, an approach that will be easy. So let's assume we had numbers such as 27 or 14. Finding their LCM using this multiples procedure might be kind of stressful, especially if you are in an exam hall, all right, and you need to save time. So I'm going to be teaching us a method which will help us to solve fractions faster. Okay, so that method will help us to find the LCM faster. Now let's treat this question again using that method. Okay, so we're going to write the same question. We have 3 over 2 plus 1 over 6. Now this method simply involves you using a table. Okay, so we're going to create a table for the denominators, which are 2 and 6. All right, so we're going to create a table like this for the denominator. So here we write 2, we write 6. Then we are going to find a number which is common to 2 and 6, all right, which we can use to divide 2 and 6. And the first number that comes to mind is 2. So we use 2 to divide both numbers. So we have 2 divided by 2, 1. We have 6 divided by 2, 3. Now moving on, the idea of using this table is to get to a point whereas your result from dividing 2 and 6 ends up being 1 and 1. Okay, so we are trying to make our result 1 and 1. Now if we are considering 1 and 3 here, which is our next result, how are we actually going to simplify this? Because if we ask ourselves for a common number that can divide 1 and 3, the only number we have is 1. And if we use 1 to divide it, we'll still be ending up getting 1 and 3 again. So what we do in such a case is that we take the other number and we use it to divide. Alright? So we are going to divide using 3. So if we divide 1 by 3, we are going to still be having 1 here. Now, normally from your normal math, 1 divided by 3 is going to give us a decimal number. But in this case, we are assuming that we are done dividing 2, alright, because we have gotten the result of 2 to end up being 1. So we have to move on to divide 3 such that we have its result being 1. So that's why we're dividing by 3 in this case. So 3 divided by 3 is going to give us 1. Alright, so now we are done and we have gotten our result to be 1 and 1. So we can now find our LCM from this table. So how do we do that? To get the LCM, you simply multiply all the results you have gotten on this left hand side of the table. So the results we got here were 2 and 3. Alright, so we are now going to multiply 2 and 3 as our LCM. So our LCM is 2 and 3. And 2 and 3 is going to give us 6. So we can see that the LCM using both methods is going to give us 6. Now, why this method is faster and better is because if you have bigger numbers, this table method, alright, will actually help you to solve it faster. Now, we haven't actually solved the fractions, but we are one step into solving it. Okay, so the first thing we did was to first find the LCM. Now that we've gotten the LCM, I will know that the LCM is 6. What we're going to do next is to simplify the fraction. So how do we go about that? Now I'm going to clear this and we're going to solve, since we now know our LCM to be 6. So recall that the fraction that we're solving is 3 over 2 plus 1 over 6. Alright, now we are actually going to write our LCM here so that we don't forget it. So our LCM is equals to 6. Now 6 is going to be our denominator for a new fraction, because when we add fractions together, the result is going to give us a fraction in this case. All right, so 6 is going to be our new denominator for that fraction. So we have 6 here. Now this particular 6 that we have here, we are going to divide each of the denominators. We are going to use each of these denominators to divide 6. Okay, so 6 divided by 2 is going to give us 3. Now the result we get from using denominators to divide the LCM, we are going to use that result to multiply each of the respective numerators. So we have used 2 to divide 6 and we had 3. So we are going to use that 3 to multiply the numerator. Alright, so 3 times 3 is going to give us 9. Alright, we'll write our plus sign. We are still going to use this 6 to divide 6 here, and we are going to get 1. Then we use that result to multiply the numerator, which is 1. So 1 times 1 gives us 1. Alright, so it means our final answer is going to be 10 over 6. So we can still break this down to give us 5 over 3. Alright, because if we use 2 to divide 10, we are still going to get 5. If we use 2 to divide 6, we are going to get 3. Alright, so we have simplified the fraction. We took it to its lowest term. Now that is how we see, that is a simple approach for actually solving fractions. But now I'm going to be showing us a more easier method, more like shortcuts to actually solving fractions, all right, or finding the LCM for the fractions we want to solve. Now the first shortcut in actually finding LCM, okay, is this one that we have here. Now it reads that when the denominators of the fractions are of same value, then that value is the LCM. So when denominators of the fraction that we're adding or subtracting are having the same value, then the value is the LCM. Okay, let's take an example. Now let's say we have 5 over 2, all right, plus 3 over 2. Now this is a fraction that we're going to add, but then this shortcut is telling us that when the denominators of the fraction are of the same value, then the value is the LCM. So we can see here in this fraction that the denominators are of the same value. So it simply means that the LCM of this fraction is 2. So we don't need to use the table method to actually solve in this case. Alright, but you can then, knowing the table method now, check it for yourself and you see that it's going to actually give you 2. Alright, so I'm actually going to do that on the side here. So let's try to use the table method. So we'll write our table. So we'll bring out the denominators here. Now, if we look for a common number that can divide both 2 and 2, the first number that comes to mind is 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. So we can see that we have gotten our results to be 1. It simply means that we're done. So the LCM is anything we have on this side. So which in this case is 2. Okay, that's why the LCM is actually 2. So can we say that? So this law or this rule or this shortcut is valid anytime the denominators, right, are same value. Do you understand? So we are now going to use the denominator, right? Denominator will be divided by the LCM, rather, will be divided by these denominators. Then we use the result to multiply the respective numerators. So 2 divided by 2 gives us 1. We use 1 to multiply 5. We have 5. All right. Plus 2 divided by 2 gives us 1. We use 1 to multiply 3. We have 3. So our final answer is 8 over 2. And that is equals 4. So that is how to go about this. So anytime you see that the fractions have the same denominator, you should know immediately that the LCM is that denominator. Now, the second shortcut states that when none of the denominators is a factor of the other, then their product is the LCM. So when none of the denominators is a factor of the other, then their product is the LCM. Let's consider an example that satisfies this particular condition. So let's say we have 5 over 2 plus 3 over 5 minus 2 over 3. Now, if we're actually going to simplify this fraction, we know that we first have to find the LCM, right? Now, but for this condition, in finding the LCM, we have to consider the denominators if they are a factor of the other. So, in this case, we can see that 5 is not a factor of 3, neither is 3 a factor of 5. We can also see that 2 is not a factor of 5, or neither is it a factor of 3. Okay? So, in this case, it simply means that none of these factors, none of the denominators rather, are a factor of the other. So what do we do in such a case to get the LCM? We simply multiply the product of the denominators together. So we are going to multiply 2 by 5 and by 3 to get the LCM. So the LCM will simply be what? 2 times 5 times 3, which is 30. So the LCM is 30 in this case. If we also use the tabular method to find the LCM of 2, 5, and 3, we'll still get the same result. So if we have 2 here, we have 5 and we have 3. So let's use the tabular method. Now, there is actually no common number we can use to divide 2, 5, and 3. So we choose the least number here, which is 2. So 2 divides 2 to give us 1. Here, because 2 will not divide this to give us a whole number, and we need to divide in such a way that we'll get the result of 1, we're still going to write down that number. So we write 5. Here, likewise, we'll still write down 3. Now, we are going to look for another number that we can use to divide 1, 5, and 3. And in this case, there is actually no number that can divide the 3 of them. So we use this next least number to divide. So this 1 has been simplified to its lowest. So we still write it here. Now, this 5 will not be divided by 3 to give us a whole number. So we still write down 5. Alright, so 3 divided by 3 is going to give us 1. So we have concluded with these two parts. Now, we are dealing with 5 now. So we have to use 5 to divide. So we have 1 here, we have 5 divided by 5 gives us 1, we have 1. So the LCM now is simply the sum of all these numbers we have here. Alright, that's the LCM. The LCM is the sum of all those numbers that we have here. So we have 2 times 3 times 5, which still gives us what? 30. 2 times 3 times 5 is going to give us 30. So the LCM is 30 in both cases. So when you see this kind of condition or this kind of fraction, and you see that the denominators are not a factor of each other, you simply know that to get the LCM, you have to multiply the product. So to simplify this fraction now, since we have gotten our LCM, we are going to use the denominators to divide the LCM and then multiply the result by the numerator. So 2 divided by 30 is what? 15. 15 times 5 is going to give us 75. So write it here, plus. Now 30 divided by 5 is 6. So we use that result to multiply the numerator. 6 times 3 gives us 18 minus. Okay, so each of these signs we have here, we're bringing them in their respective position in the fraction. So we use 3 to also divide 30. So 30 divided by 3 is 10. We multiply that result with the numerator. 10 times 2 is 20. So we have 75 plus 18 minus 20, and that result is 73 over 30. So we can see we are done simplifying this fraction. Alright, but the core or the key point that we need to take note is that in this kind of condition where the denominators are not a factor of each other, alright, the product of those denominators will be the LCM that we're going to use to simplify the fraction. Okay, so let's look at the third shortcut, okay, which is actually the last that I'll be showing us here. Let's consider it now. Now here's the third shortcut, and it says that if the smaller denominators are factors of the bigger denominator, then the value of the bigger denominator is the LCM. If the smaller denominators are factors of the bigger denominator, then the value of the bigger denominator is the LCM. Let's consider an example in this respect. Let's say we have the fraction of 3 over 2 plus 4 over 8, and we want to simplify this. We all know that we need to first get the LCM. But in getting this LCM, what's the shortcut here? The shortcut is that we have to consider denominators. We consider the small denominator and the big denominator. If the smaller denominator is a factor of the bigger denominator, then the bigger denominator is the LCM. So we can see here that 2 is a factor of 8. So the smaller denominator 2 is a factor of the bigger denominator 8. So it simply means that our LCM is the bigger denominator, which is 8. Okay, so 8 will be what we'll be using to simplify this fraction as our LCM. So if we also use the tabular method to get the LCM of 2 and 8, we'll see that our result will also be 8. So let's try it. So we have 2 and 8. So there's a common number that can actually divide 2 and 8, and that's 2. So 2 divided by 2, 1. 2 divided by 8, 4. We can also use 2 again. 2 divided by 1, it will still bring down 1 because we're done simplifying that part. 2 divided by 4 is 2. We can still use 2. Alright, we have 1, we have 1. 2 divided by 2, 1. So we know that the multiplication of everything we have on this part is our LCM. So 2 times 2 times 2 is going to give us 8. So we can see that in both cases, 8 is the LCM. So you need to know when to apply these shortcuts, and you need to know when to use the tabular method straight away. Alright, so in such a case where you don't have any of these conditions, just make sure that you use the tabular method straight away. Alright, so let's simplify this fraction. We have 8 divided by 2 is 4. So we multiply that by the numerator, and that's 12 plus 8 divided by 8 is 1 times the numerator, that's 4. 1 times 4 is 4. So we have 16 over 8. Alright, and 16 divided by 8 is going to give us 2. So we are done simplifying this fraction. So now we know when to apply this condition. We apply it when the smaller denominators are factors of the bigger denominators. Now there's also something I'd like to show us. It is called expansion of fraction, and I'll also be showing us how to simplify algebraic fractions. So let's see this real quick. Now in the idea of expansion of fraction, this is just simply the breakdown of a fraction that has the plus or the minus sign at the numerator. So it's a breakdown of a fraction that has the plus or minus sign in its numerator. So let's say we have a fraction such as 3 plus 2 over 4. In this case, because we have an expression here, we have 3 plus 2 here at the numerator, and we just have one number at the denominator, we can simplify this fraction, alright, by saying that the result will be 3 over 4 plus 2 over 4. So the idea of the expansion of this fraction is that each of the numerator is being divided by the denominator. Do you understand? So this applies in every kind of fraction that's in this format. So it doesn't matter how many operations you have at the numerator. It can be, let's say you have 3 plus 2 minus 4. Each of those numbers are still going to be divided by the denominator. Do you understand? But now you need to know that this expansion of fraction is applied only when we have plus or minus. Okay, so if in a case we have, let's say, 3 times 2 over 4, we're not going to say it's 3 over 4 times 2 over 4. No, it doesn't work that way. This expansion of fraction, all right, in this similitude only works when we have plus and minus. So that's that for the expansion of fraction. You can simplify further. We have 3 over 4 plus 1 over 2. All right, so that's just that on expansion of fraction. Now, simplification of algebraic fractions. Let's say we have an algebraic fraction of, let's say, 2 over 2x, all right, plus 3 over y. Now, how do we simplify such? Now, you know already that in simplified fractions, we need the LCM. So how do we get the LCM of denominators of 2x and y? We can use the tabular method, but in this case, using tabular method will not actually be the best approach. The best approach to finding the LCM is to multiply the product of the denominators, or to get the product of denominators rather. So you multiply the denominators of the product. Sorry. So you multiply the denominators, all right, to get the LCM. That's just the idea. The best method is to multiply the denominators to get the LCM. So if we multiply 2x by y, we're going to have 2xy. So it simply means our LCM is the product. So in every case for algebraic fractions, always multiply the denominators. All right, that will be what we'll be using as our LCM. Do you understand? So we divide 2xy by 2x. When we divide, we're going to have y. We multiply that result by the numerator, so we have 2y plus. We divide 2xy by y. All right. When we do that, we're going to have 2x. We multiply that result, which is 2x, by 3. We're going to have 6x. So we are done simplifying this algebraic fraction. All right. And here we have it. So we can see that if we actually look at the expansion of fraction, we can take this back to this. Okay, by attributing or by dividing each of the numerator by the denominator. So you can see we have something like this. All right, so y is cancelled out here, 2 is cancelled out in this respect. All right, but let's leave it the way it is so that we can see how we arrived at that. So we are having 2 over 2x, all right, plus this can cancel this, x cancels out x, so we have okay, 2 can also divide this, so we have 3 actually. So we have 3 over y. So we can see that we have what we have here is also what we have here. So that's the idea of this basic math. All right, so I've noticed that a lot of students have problem with this aspect when they are attempting questions, so I decided to treat it once and for all. So if you like to get content like this on other topics like indices, logarithms, matrix, determinants, and other core math topics, do well to subscribe to this channel. Turn on the notification bell so that you can receive a notification anytime I post an update. Now, before you go, I want you to know that I have a Telegram channel where you can get access to very important math textbook, all right, well-detailed math textbook on all the math topics you need to know when sitting for an external examination. If you're Nigerian and you're sitting for external examination like JAMB, WAEC, NECO, and the likes, this textbook is going to be very helpful to you. So check the link in the description to get access to the Telegram channel.